Good day, ladies and gentlemen. Today we are going to start the first lesson of Chapter 4, which is on exponents. And we'll start with 4 vocabulary words. First one is exponent. An exponent would be how many times a number is to be multiplied by itself. So that would be, when you look at an exponent, you have the little number that is above a bigger number, would be the really simplistic way of saying it. A base would be the number that the exponent tells how many times it should multiply by itself. And if you look at the example below number 4 here, the number 2 is labeled as the base. A power is a number produced by raising a base to an exponent. So in our example here, we have 2 to the third. We would actually call that a power. And then if you get an answer or evaluate 2 to the third, you are going to get 8. And that could also be called the power. So it's the number produced by raising a base to an exponent, or it could actually be a number in exponential form like 2 to the third. And the blue down here explains that a little bit further. And the last one is exponential form, which would be the example below. 2 to the power of 3 would be something in exponential form. Skipping down, number 5. Write the examples in exponential form. I'm guessing this is review for most of us, but we have 4 times 4 times 4 times 4. We have 1, 2, 3, 4 4s. So our base is 4, and we're going to multiply it by itself 4 times. In this case, we're just using exponents. We got 1, 2, 3, 4, 5, 6. So we have x going to be multiplied by itself 6 times. And in this case, we've got a couple of different things going on here with the number 7 and with the letter y. So in this case, we are going to count our 7s and we get 2. And we're going to count our y's and we get 3. And so we're going to express this as 7 squared times y to the third. And we do want to make sure that we put the number, if you have a number and a variable together, you want to put the number before the variable when you're writing in exponential form. And that's very much the same when you are writing algebraic expression that's being multiplied. The number should always come before the variable if that algebraic expression has a number and a variable. This one says evaluate now, which means give me an answer. So 3 to the third is just like saying 3 times 3 times 3, which is 27. In this case now, we don't have 3 to the third, we have negative 3 to the third, and that would be very much like saying negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is 9, and we're going to multiply it by the last negative 3. So this answer is actually negative 27. Negative 2 squared would be negative 2 times negative 2, which is going to give us 4. Negative 2 times negative 2 is a positive 4 because we're multiplying a negative by a negative. In the last one now, we got to be very careful here. We have a negative on the outside of the parentheses. So what we want to do, and then we're squaring whatever's inside the parentheses. So what we want to do is we want to square negative 2, or multiply negative 2 by itself twice. So negative 2 times negative 2 is equal to 4, but then we can't forget about this negative sign. We do nothing with it except for attach it to our final answer. So our answer is negative 4. Really, this problem is saying, what is the opposite? Negative means opposite. What is the opposite of negative 2 squared? Negative 2 squared is 4. The opposite of that is negative 4. Number 7. Problem like this. Evaluate x times y to the x minus m to the y plus x. And we, or wherever the problem is coming from, gives you what each of these shall represent. This is just simply an order of operations problem. It is plugging in numbers for your variables. So we would rewrite this problem. I did not leave myself much room to do this. We would rewrite this problem as 4 times y, which is 2, x again is 4, so 4 times 2 to the fourth, minus whatever m is. Oops. I'm going to delete or erase this and start over here. So we've got 4, which is x, and we're going to multiply that times y to the x, so it would be 2 to the fourth. Then we're going to subtract whatever m is, in this case 3, to the second, because it says to the power of y, plus x, and x again is 4. So I'm not going to actually solve this problem with you because we've done plenty of this through the first 3 chapters. You are going to do what's in the parentheses first, you are going to multiply second, and then you're going to tack on your 4 at the very end and get whatever the answer is. Number 8, diagonal. A line within a shape that connects non-consecutive vertices is what we are going to call a diagonal. Some more vocab for you. Number 9 are vertices. So if we're not quite sure what they are, here's your definition. It's a point in which two sides of a shape come together. So if I have a triangle, I'm going to have a vertice, or a vertex, and another vertex, and all three of them would be vertices. We have 3 vertices in a triangle because it's the point in which two sides of a shape come together. Last thing then would be the formula for number of diagonals in a shape. This is something I do expect you, or I am going to expect you to know. The formula for the number of diagonals in a shape would be 1/2 times n squared minus 3 times n. This is going to be useful not only for this chapter, but when we get to geometry and we need to calculate the number of diagonals in a shape. So here's my shape. I want to know the number of diagonals. So a line within a shape that connects non-consecutive vertices. So I want to know, how do I calculate the fact that a square has 2 diagonals? Now we can draw a square and we can draw our diagonals within the square and know that the answer is 2, but let's actually plug it into a formula just in case we get to a shape in which you have tons of diagonals because it is like a 7 or a 10 or a 12-sided shape. So in this situation, we are going to take 1/2 times n is going to represent the number of sides. Okay, n equals number of sides of a shape. Okay, so it's very important to understand what n stands for. We got 1/2 times n, so our square has 1 side, 2 sides, 3 sides, 4 sides. 4 sides, we're going to square it, and then we're going to subtract 3 times the number of sides again, and that's all going to go within parentheses. Order of operations, 1/2. Within the parentheses, we've got 4 squared minus 3 to the 4th. We know we do exponents first, so we got 16 minus 3 times 4. I'm going to go the long way here. In the parentheses still, we've got the number 16. We've got 3 times 4, so we know we're going to do the multiplication first. We got 16 minus 12. We still have parentheses, so we're going to do 1/2 of whatever 16 times minus 12 is, which is 4, and 1/2 of 4 is going to give us our answer 2. When we go back up and look at the shape, we already know that a square has 2 diagonals. We proved it, or our proof was plugging in the number of sides for n in that equation, 1/2 times n squared minus 3 times n. Good luck on your assignment. Good luck on your work.